Hello everyone, my name is Rodrigo and today we're going to be solving Advent of Code Day 5. So welcome to the stream. If this is the first time you're watching, I just want to give you a disclaimer. I have solved the problems already. As you can see, let me move my face out of the way. As you can see, I solved Day 5 already, so this is not me solving the problem for the first time. This is me giving you a more an attempt at a more pedagogical walkthrough of a solution. I will not be showing the most efficient solution of all. I'm going to walk you through the reasoning I was going through when I solved the problem, and we're going to see how you could think of a similar solution and how to write it. Hello from Paris, says Roger in the chat. Hello from Lisbon, Roger. It's nice seeing you here. Hola, Ange, welcome. Alright, folks, so as usual, if you have any questions throughout the stream, feel free to let me know. If something isn't clear, also let me know. If I make a bug, if I have a bug in my code and you spot it before I do, just tell me, alright? You can tell me and then we can fix it immediately. So the problem statement, I'm not going to read the full problem statement, I'll just give you the gist of it. Our input will look like this, a sequence of ranges, which are hyphen separated numbers, and a sequence of integers. And for part 1, we need to figure out how many of these integers in the second section of the input fall within any of the given ranges. For example, for the example input we have, the number 1 does not fall into any of the ranges. 5 does, because the ranges are inclusive on both endpoints. So the 5 does, so that's going to be 1. The 8 doesn't fall within any range. The 11 falls within the range 10, 14, so that's 2. The 17 also falls within a range, so that's 3. And the 32 is outside all of the ranges. So the answer for this example input would be 3. And we need to do this, but for a much larger input, which is this huge text file. And the numbers themselves are huge. So I'm going to go back. I'm going to save this input. And let's do this. Where is this? AOC, day 5. All right, we have the input. Now we can solve the problem. Let's create a file for the solution. Now the very first thing I want to do is parse my input, because this time I have two things to get from my input. I need to get the ranges first and then the integers, the isolated integers. So I'm going to open my file, and there's something cool I want to show you. And I'm not sure if you're going to like it or not, but I'll do it. So I want my, what are they called? The ranges. It's going to be an empty list. And now what I can do is go through each line like this. And what I know is that this allows me to go through the file, to the line, through the lines of the file until I reach the empty line, which is the separator. So go through the lines with ranges until I hit an empty line. So I'm using the special form of the built-in iter. So for line in iter, I want to build a range. So I'm going to have the left and right endpoints. They're the integers I get if I take the line and split it on the hyphen. And then I'm going to append the range as an actual Python range. Because when I read the problem statement at first, I thought of building the range with the built-in range, because built-in range has containment checks. I can do something like 3 in range of 1,5. Like, I can do this, and this is very efficient. So I thought, yeah, let me just use the built-ins for this. And now the for loop here goes through the first section of the file And then if I write a second loop, I'm going to go through the remaining lines, which will be the isolated integers. So I already skipped past the ranges, now I get the integers. So the product, the IDs, I think these are IDs in the problem statement. Yes, IDs. So the IDs, this is an empty line. This is an empty list, and now I do IDs.append the integer version of the line. Or I convert the line to an integer and I append it. And then I just return both things. And this lets me parse my input. Now let's see if I got this right. If name is main, so Paramesh says that this is cool, the iter trick. I think it's cool. I'm not sure if this is a party trick or production code. And then Anje wants to do... you want to split. Yeah, but that assumes you have the whole thing in memory. And, well, yeah, the file is big, but it's not that big, so I can definitely read the whole thing. But I like to write code that doesn't load the whole input into memory if I don't have to. But I mean, potato, is it going to make a big difference? Nah, not really. I just like excuses to write exotic pieces of code. So I'll take any opportunity I can get. And by the way, this is, at this point, we're only left with the IDs inside the file. All right. So now let me print a couple of ranges, just make sure that I didn't mess anything up. All right, so we do get a few ranges. Now, to solve part 1, all I need to do is go through my numbers and check if there's any range that contains them. So for part 1, I get my ranges and my IDs. I want to count the number of ranges, sorry, the number of IDs that fall within any range. So what I'll do is for each ID, the reason is ID is a built-in and I don't want to overwrite it because I don't like the syntax highlighting throwing me off. So for each ID in the IDs, the count increments depending on whether there's any range that contains the ID. So if each ID in a range, every word here means something in Python. So for each ID in range, for range in ranges. And then we just return the count. Now what's going on here, the built-in any, very useful. So this is similar to doing something like for range in ranges, if ID in the range, then count plus equals 1, and then break. Because as soon as we find 1, we don't need to keep going, obviously. But I like to use the built-in any because it's going to do all of this work for me, of the checking and going through the ranges. Now let me print the answer. Let's see if this is correct. Part 1, ranges, IDs. We run this. 679. I don't remember what my solution was. 679. All right. So part one is done. Let me show the code. Yeah, I mean this is the important part, and this fit in a, the font size is, yeah, this fits nicely. All right, questions about this? Alright, no questions. I'm just starting a poll for the sake of it. So I'm curious to know whether you folks think this is just a party trick or if it's decent Python code. So let me know, it's just a party trick or it's production code. Alright. So you'd say party trick. Yeah, I mean, I don't know. Ether can be used like this. So I'm not forcing it too much. I mean, I know sometimes I kind of bend the expectations of, like, I bend what's expected of a certain function, but this doesn't look that weird. Just uncommon. All right, but yeah, let's not waste too much time there. So what's part 2? So part 2 cares about the same, well, naturally about the same input, but we don't even care about the IEDs this time. We only care about the ranges, and we're supposed to find the total number of integers that fall within any of those ranges. So instead of checking if specific IDs fit in the ranges, we need to figure out how many numbers fit in those ranges. So let me draw a quick diagram. So when I read this, the problem here is not computing how many integers are inside the range, because that's just going to be subtract the right endpoint from the left endpoint and add 1. But that's for a single range. The problem is, what if the ranges overlap? So before computing, or before figuring out the length of each range, you need to compare the ranges among themselves and determine whether they overlap or not. Because if they do, you need to do something about it. Otherwise, the result is going to be off. So as a simple example, if you have, let's do from the input here, 1014 and 1218. All right, so this is 1014 and this is 1218. Right? So within the first range, how many numbers fit? Well, there's going to be 10 and 11 and 12 and 13 and 14. So there's 5 numbers in here. And for the range 12 through 18, there's going to be 13 and 14 and 15 and 16 and 17, but also 12 and 18, so that's 7 total. But together, if you look at both ranges at the same time, they only hold 9 elements. So both at the same time only hold 9, not 5 plus 7. So I think this part is easy to visualize. So now the only thing that is left is deciding how you want to take care of the overlaps. So in this case, there's an overlap here. What do you do with this? There's plenty of things you can do. For example, you pick one of the ranges as the reference range, like the one that's set in stone. And then when you compare a second range with your reference range, if they overlap, like in this case, what you do is you delete the overlapping part. So because they overlap here, you just get rid of this part. You delete it, and you're left with a smaller range from 10 to 11. And here it goes from 10 to 11, not from 10 to 12, because the 12 is inclusive, so we don't want to double count the 12. So that's it. This is a fairly straightforward way of thinking about the problem. Now there's lots of clever things you can do to make this process very efficient, but when I was solving this the first time, I didn't make it very efficient. I just went through the ranges. I take a range to be the range I'm processing now, and I compare my range, the processing range, with every single range that has been processed already. I shorten it whenever needed, and in the end I take what's left and I mark it as having been processed, and I just do this iteratively. So how does this look like in code? For part 2, I only need my ranges. By the way, if there's any questions about the idea of slicing the ranges, getting rid of the overlap, let me know. So for part 2, I'm going to say that the processed ranges is a list. It starts off as an empty list because in the beginning I haven't processed anything, and now it's more useful to have the endpoints than it is to have the built-in range. And I don't remember if you run Python. If I have a range, can I don't remember if this has attributes that let me. Oh, it does. All right. So I get the start and stop endpoints of a range. But then the stopping endpoint is going to be 1 plus what I had originally. So to make my life easier, I might want to work just with the, what's it called? Just with the endpoints. Okay. So we'll do for range in ranges. Now I need the start and the stop of the range. Range.stop. But this stop, I had to increment it up here to make it inclusive. So now I need to decrement. So now I'm back at the original integers. Was this worth it then? Maybe not. Maybe not. Maybe I should have just worked with the integers the whole time. Now what I'll do is, for each processed range in the processed ranges, and these are the ones that are set in stone, the processed ranges, I'll get their left and right endpoints. So I can actually do that while going through the loop. And now I need to check if they overlap in any way. And there's a couple of things that can happen. They can either overlap on the left. So if the green is the processed one, they can overlap on the left. They can overlap on the right. They may be contained, maybe let's write it here, they may be contained inside the processed range, or the one you're taking care of now might be larger than the processed range. So these are the 4 overlaps that you need to take into account. And also, but those situations are okay, they might be completely on the left or completely on the right. And in those cases, you don't need to do anything. But you need to be careful about checking those things. And intersections can be a pain to work with. But one thing you can do is figure out that in plenty of these cases, you just want to check if the endpoints are inside your reference interval. So what you're going to do is you're going to take the right endpoint of your range and you're going to check if it's inside. And if it is, you move it left. So it's completely on the left. You're going to also take the left endpoint and you're going to check if it's inside. Because if it is, you're going to move it to the right. So it's completely outside, like here. And if it's completely inside, then by doing this process of moving the right endpoint to the right and the left, so the right endpoint went to the left, and the left endpoint went to the right, you're going to end with a reversed range. And because it's reversed, it means it should be empty. And so you can skip it. But you're going to do this by working with the endpoints one at a time. So how do we do this in code? Well, you're going to check if the left endpoint is inside the range. Because if it is, you need to move the left endpoint to the right. So this situation is when the left endpoint is inside the range, which is any of these two cases, here or here. Independently of that, so it's not an elif, independently of that, you're going to check if the right endpoint falls inside the range, because if it does, you want to move it left. So you're in one of these two scenarios, right endpoint, the right endpoint, and you want to move it to the left. And then, when you're done doing this, if your left endpoint is now to the right of your right endpoint, it's because this range became empty, so you can skip it. So you want to break, there's no point in comparing your range with the other processed ranges because you already know this is empty. And once you're done once you're done shortening your range, which is this process, you want to take whatever was left and you want to append it because it now has been processed. Now the thing is, you only want to do this if your range is not empty. So you can either check this again. So in this case, you want to check if it's valid. You can do this. Or I prefer to use an else here with a for loop. So this only runs, the else only runs if the break didn't run. So we append the range only if we didn't break from the loop. And when we're done processing all of the ranges, we're going to count their amplitudes. So we go through each range again, and we append to the count. And we return, and we run this. Now there's a problem here, 365.0.11, 365.0.11. So the correct answer is 358 something, and I have 365 something, which is too large. What's the problem with my code? Now this code is wrong in the sense that it doesn't fully implement the process I described. So can you folks figure out what I left out? What do you mean, Anje? The processed ranges can also overlap. Overlap in what ways? Because supposedly what I'm building is a list of ranges that do not overlap. And if they overlap on the ends, or if the new range is contained within any of the processed ranges, that's taken care of. So there's a very specific situation that I missed. Now I missed it on purpose. Well, no worries, folks. It's from looking at the code, it's not obvious. When I was solving this, I also missed it, and believe me, it took me a while to figure out what I was leaving out. So the problem is, and maybe you got it, Anje. Maybe I don't exactly know what you meant when you said overlap, but the situation I left out is when the incoming range contains the processed one, because in that case the left endpoint is going to be to the left, but the right endpoint is going to be to the right, so there is a big overlap, and I'm not accounting for that. Now at this point I was thinking, how can I fix this? Because once I put a range in my list of processed ranges, I can't modify it, because if I do modify it, I need to recheck it against every single other range that has been processed already. So my thought was, okay, if I find a range in this situation, a range that is too long, I'll slice it on both ends. I'll get rid of the intermediate part. And since now I have two ranges, I'll take one of them and I will mark it to be processed later. So I'll just take care of one of the ends now, and I'll take care of the other end later. So that's what I decided. That's what I decided to do, and that's how I decided to fix this. So what this means is, instead of just accepting the list of ranges here and going through it, I need to use a while loop, because this is now going to be a queue of ranges to process, and I cannot modify this list while I traverse it. So what I'll do is, ranges to process starts by being all of the ranges I got from my arguments for range in ranges. And now what I'll do here is, while I have ranges to process, I'll take one and pop it. All right, and now I need to check that situation. Is the incoming range, or does the incoming range contain the range to be processed? Because if it does, I need to split it. So if left is to the left of PL, which is to the right of PR, which is strictly less than right, then the processed range is contained inside the range that I'm working on right now. And so what I'll do is, I'll take a look at the list of ranges to process, and I'll append a new range that starts at PR plus 1 and goes up until the original endpoint. And now I'll shrink the current one I'm looking at to end immediately before PL. So this means now I'll work with the left one, and I'll mark the right one to be processed later. And then I keep going, comparing whatever I have with all of the other ranges to be processed. Does this make sense? I hope it does, because it's supposed to work. So let's see, UV run solution. 358, 155, 358, 155. And then ends with 4116, which is also what I got. All right. Well, this was my solution. It's not... What's the complexity here? All right, so in terms of the length, the length of the list of ranges, so in terms of the number of ranges we have, my solution is quadratic, because I'm going through... strictly speaking, it might be worse if there's lots of full overlaps, because then this might become really large. But let's just say it's quadratic because there's two loops doing some work, and you can write solutions that are at least, I'm not sure if there's anything better, but you can do something that's O of n log n. If you're clever about sorting your ranges first before you start to process them. Because the problem with my solution is that although I know I can somehow normalize my ranges, while I know I can create a list of ranges that have no overlaps, I have no control over the types of overlaps that I might get, because my ranges come in at an arbitrary, or come in an arbitrary order. And if you're clever about sorting your ranges beforehand, you can simplify your code that handles the the normalization, and you can make the whole thing more efficient because it will require less comparisons. Yeah, it's pretty cool stuff. All right, the problem is solved. I don't see any. I can't think of any interesting ways of creating a visualization for this. Let me think. No, I don't think so. So I'll give you a second to make any comments or to ask questions if you have them. Otherwise, I think we'll call it a day. We'll be back tomorrow at 5 p.m. UTC again, but we might do a shorter stream today. I'll check. I asked for ideas on social media, but I don't think anyone had any good ideas, any good suggestions. Let's see. Nope. All right. So no one said anything useful in social media as per usual. So we will call it a day. All right, everyone, thank you so much for watching. We'll be back tomorrow at 5 p.m. UTC to solve Advent of Code Day 6. If you haven't already, try to solve part 2 in a more efficient way. So this is decent, but don't settle for decent. Make it very good. So try to solve this in a more efficient way. And I'll see you tomorrow. Bye.